Hi, everybody, and thank you for inviting me. And I'm pleased to be here and present have this presentation on 5G. I'm Xhafer Krasniqui. As Pascal mentioned, I'm part of the Spring project. I work for Digital Catapult as one of the partners of Spring project, and I'm the 5G technical lead for the Spring project, responsible for the building and the operation management of the test beds we have as part of Spring that Helena mentioned earlier. Okay, I'm not sure about the expectation of the audience here, but the way I structured this was just to talk about what 5G is, 5G's capabilities, and how towards the end, how important, why 5G is important for in practice, and specifically with a focus on environment, which I think seems to be the theme of this event today. 5G has been a buzzword for the last few years now. I'm sure most of you, a lot of you know quite a bit about 5G. It's the 5th generation of mobile, although it's the next generation after 3G and 4G and so on. I always like to say, and I'm convinced is that way, that 5G actually is not just the next generation of cellular networks. It's different, in my view. It is different because it provides a better user experience. It's not just a connectivity network. It's more software-defined centric, which makes it more flexible and more agile in terms of the adjustments to the needs and requirements that, given that we live in the IoT era and robots and drones, all that, 4G was not good enough because 4G was more kind of a one single network, not one size fits all. But we live in a different time now, and we needed a different technology that would be tailored or be able to be tailored for specific use case and requirements. And that's where the idea of 5G comes from, and that's actually how the development on 5G was focused. 5G is expected to transform the business and the way we work and behave, unlike other generations of mobile cellular. While in 4G, we had mainly the focus on consumers and connectivity of consumers, the focus on 5G actually is connecting everything everywhere. And it's just providing a much better user experience than other generation provided. When the players or industry players started to think of new generations, they came up with some drivers, with some key capabilities that they said we need to have a technology that would do these things. And those three capabilities, as you can see in the diagram here from this famous triangle, are the need for more mobile broadband, the need for massive machine type communication, which means very high density of connectivity of IoT devices, and these days we talk in billions of them, and also a technology that would provide a very sophisticated reliability connections and also very low latency. So these are the three drivers that have driven the industry players, vendors, and operators to develop a technology like 5G, for example, that would be able to provide all these services under one platform. I agree with some of you sometimes that may think that some of these applications can be supported by 4G. That's correct. And the diagram here actually shows that as well. But it doesn't support to the scale that what 5G would do. It doesn't go far enough in terms of latency, for example. 5G can provide the latency down to, okay, I hope you can still hear me.
Yes, we can.
Okay, so 5G provides the latency all the way down to 1 millisecond or even lower, with the high density up to 1 million IoT devices within a 1 square kilometer, which is very, very high density, and also can provide massive broadband to the scale of 10 gigabit per second. So some of these, as I said, can be supported and provided by 4G, but not to the scale that 5G does, because 5G was designed and developed with these capabilities in mind to support and to go extra mile to support these capabilities that would be needed and required by the industry. 5G is a cellular technology. It's a new generation, and in terms of the structure, in terms of architecture, it's similar structure. It has the core, it has the transport side, the radio side, and the terminal side. So in that sense, it's similar to 4G and 3G, and actually that it has inherited quite a lot of features from those previous generation, but as I keep saying, it goes extra mile to provide additional capabilities that no other technologies could do that. It's very important to mention here that in context of 5G, although all the generations support and need spectrum, when it comes to 5G, 5G uses different spectrum, which we'll see a bit later on. How does 5G compares with 4G? It overperforms in a number of aspects, like spectrum efficiency. In 4G, spectrum efficiency was utilized okay, but when it comes to 5G, it's 3-4 times better, which means we provide more bits per hertz. And that is achieved through small cells and the high density of cells that provide this kind of low range, short range, but the spectrum efficiency increases drastically here in the case of 5G. Latency, as I mentioned, is much better than 4G, about 10 times. Throughput also very high. Actually, this shows 10 times, but now the latest development I've seen, it goes even to 50 times better than 4G. We shouldn't forget that even 4G has improved in the meantime, and it can go up to around 100 megabits per second. But 5G can go to 10 gigabits per second or even more once we start moving to millimeter wave spectrum. Connection density, again, it is much better as 4G. In the case of 4G, the maximum number of connections in the IoT sector can be supported is around 100,000 per square kilometer, while in 5G can go up to 1 million devices per square kilometer. It supports more capacity, more users can be connected, more devices can be connected, and overall it's much more efficient in terms of the environment and energy efficiency. Actually, 5G is considered to be about 90 times or 90% more efficient than 4G in terms of the energy efficiency. Spectrum, because it's a cellular network, spectrum has a key role to play in this case. But when it comes to 5G, because it supports a wide range of use cases and applications, those can be supported with one range of spectrum. That's why 5G was built to support like low spectrum below 1 gigahertz in order to support the connections that would penetrate deep in difficult zones and areas, and it would also penetrate like buildings and trees and so on. The other range is between 1 and 6 gigahertz, which is the range that we use as consumers, but also the industry mainly uses, and that is between 3.4 and 3.6 gigahertz. And actually, this is the most crowded spectrum for 5G. Although now with the Ofcom and other bodies, they kind of making more spectrum available. The focus of 5G now is at the moment is in this spectrum range, like 3.4 to 3.6 gigahertz. And actually in Europe and Asia, this is the spectrum that we've seen most of deployment so far. In US is a bit different because they are kind of moving towards millimeter wave a bit faster. But again, how we decide as what spectrum to use is mainly driven based on the use case and applications and the need for latency and broadband and so on. And another range of spectrum used by 5G is over 6 gigahertz, and that includes millimeter waves, gradually moves towards that. As you can see here on the right-hand side, the diagram here shows the relationship between the spectrum used and the range, the coverage, and the latency. The farther the antennas or small cells are apart, as part of the physics law, the latency is higher. But because in 5G we're talking about high density of small cells, that range gets smaller and smaller, and as such the latency gets improved a lot. We will see later on when I talk about edge computing, which is one of the key elements to improve the latency. So when we have cases like IoT devices where the coverage is important, not necessarily the data rate, then we use lower spectrum, because signal, as I said, can travel deeper and easier and farther. And somewhere in the middle, if you have, for example, a combination of different use cases like AR, VR, or immersive technology with the need of kind of good user experience, then we kind of focus more on this 1 to 6 gigahertz spectrum, which, as I said, is the most crowded and most used for 5G. Given that spectrum is never enough, Ofcom is making more spectrum available, and Ofcom at the moment is looking more at the shared spectrum. Shared spectrum is the range between 3.8 to 4.2, which at the moment is not very crowded, and it's kind of more for local context. Decision on this spectrum is more local based, and it does not belong to the operators, as opposed to the shared spectrum 3.4 to 3.6 that belongs mainly to MNOs, and even for private use, we have to apply for that spectrum from Ofcom, and Ofcom has to consult the MNOs because MNOs own that spectrum. When it comes to the shared, no, this is, as name indicates, it's to be shared by the others more on a local context and basis, and to be used mainly to drive innovations and research and trials purposes. And in this context, as I said, we have 3.8 to 4.2, but we also have some shared spectrum in band 3, 18 megahertz, or 23, which is B40 or band 40 megahertz. So this is the range where we can see this shared spectrum that, as I said, Ofcom on purpose is making available mainly to drive innovation, research, trials, and testing. As for the millimeter waves, Europe overall, in general, and UK as well with that, we're going quite slow towards that compared with US. The reason is that there is no demand, and the spectrum we use at the moment is good enough to provide for what we need at the moment. But we're gradually moving towards that as well. And once we move to millimeter wave, we can provide a data rate up to 2-3 gigabit per second, or even up to 10 gigabit per second. But again, these data rates are not available and possible today because they have to go in line with the specifications from 3GPP, which is the main body for specification of 5G and other cellular networks. But more, I got the slide later on that. 5G architecture initially has two versions. One is reference-based, which kind of inherits most features from 4G, and kind of it builds more on the interface and reference points that elements and different functions talk to each other. But the other architecture design and more popular and more widely used is the service-based architecture. And actually, this is what makes 5G very important, very, very powerful network, because it makes more kind of granular in terms of having elements talking to each other when needed and as needed, as opposed to the reference one was more kind of rigid and strict, and only between the specific elements through network interfaces could be talking and making use of each other's. So service-based architecture, as I said, is very important. This is what drives mainly the adoption and implementation of 5G. And it's very important because it's more kind of self-contained, independent, reusable, and it also supports service discovery, load balancing, and encryption better than the other version of the architecture of 5G. In terms of deployments, a lot of discussion has been going on different types of deployment for 5G during the last few years. I'm not going to go through all of these because there are so many, I probably need half an hour to explain. The way it works is that when it comes to the implementation, we have three types of implementation. One is a standalone, which means can be a 4G standalone, which means a 4G radio or eNode B talks to the core, and the 4G core is called EPC. Or we can have a standalone 5G where a 5G radio, or it's known as NR or GNode B, talks to the 5G core. But because we are not there yet, kind of, well, actually, just this month, we're going to see more standalone deployments. But until now, we had to rely on non-standalone deployment, which means we had to use 4G cores, EPCs, talking to the 5G radios in order to increase the throughput and the data rate. But the communication, the signaling part, still goes over 4G. So it requires 4G, and 4G in this case would serve as an anchor point. to manage the signaling part, the control part. But when it comes to the user plane, data rate, that would go over 5G radios. And with that, it would increase the data rate. With this deployment, we can have an improved data rate, but not to the full potential of what 5G claims it can do. So at the moment, we can have like data rates up to 1 gigabit per second. In our test bed, actually in West Midland that Helena mentioned earlier, we use the non-standalone deployment, but we're going to upgrade to a standalone very soon, like within a month or so. And at the moment, we can provide up to 700 megabit per second data rate in our test bed. But once we upgrade to standalone deployment, which, as I said, is going to be around the July timeframe, we should expect even more or even higher data rate. But one thing we need to bear in mind that it is the spectrum that dictates the speed, the data rate as well. And at the moment, we have only 100 megahertz because no vendors or no radios from vendors support more than 100 megahertz in one range. So these limitations are still present, but overall, the technology itself can support much higher data rates. Some people may think that, oh, 5G is great, it can do everything on its own. Well, that's not very true, because there are other technologies that made 5G possible, that help 5G come to the stage where it is today, or to the stage where it will be tomorrow. These technologies are service-based architecture, which I explained previously, edge computing, MEC, or multi-edge computing, SDN NFV, network slicing, cellular IoT, small cells, and massive MIMO. These are the key technologies or enabling technologies that have made 5G possible. Otherwise, 5G would not be. Not all these technologies were developed because of 5G. Some of them started even earlier, and they were kind of started with 4G in mind. But with 5G, they were further enhanced and kind of helped to make full use of these technologies for specific use cases that 5G can support and provide. Edge is very important because it brings the ICT part to the edge of the mobile network. And one specific use of MEC in this case is to reduce the latency to the level that some use cases need, for example, autonomous cars or remote surgery or telemedicine and so on. So through Edge, not only that we provide the local breakout, which means not having to go through the transport side, but also it provides a mini core network to the edge, closer to the customer, and as such helps to reduce the latency. And a lot of decisions are made on a local level without having to go all the way via core, which in that case would lead to the delays, but also would overload the transport side and would cause congestion and so on. So it's very important. MEC is important because of the need to have this ultra reliable and low latency communication, as I said, by being next to the or closer to the customer. Some of the use cases that are supported by MEC and relevant in 5G are immersive technology applications, for example, AR, VR, automotive, transportation, all these that require critical or where latency is very critical. There is no clear decision or definition as where MEC should be, kind of in terms of the locations of it. It all depends and is down to the service providers to decide where they want to keep it, based on the demand, based on the needs, and based on the requirements of specific use cases that come from customers or from private customers or companies and so on. So MEC, it's down to the operator, the service provider to decide as where they put it, whether they put collocated with the radio or at the edge of the core or even closer to the customer on next to the device. SDN is an NFV, they go in tandem. They both, when they go in tandem, provide network efficiency and improve network automation, make 5G very flexible. First, SDN, it separates the control plane from the user plane and centralizes the control plane. And after that, using the software, it makes 5G very flexible in terms of the adaptation and modifications based on the needs. And also kind of enhances the security because user plane and control plane become separate and not necessarily are targeted or at the same time. So they get separate security and isolated security, which in this case is very important. On the other side, visualize NFV or visualization, it visualizes the key functions of 5G and makes use of those and adjusts those functions based on the needs and then the requirements coming from the different use cases. This is just an example to see how in the past a traditional network was very rigid and any changes or enhancements would require changes to the hardware part, and every hardware would have the operating system and applications, while now with the SDN networks enabled, we have a common API that talks or enables the communication between the hardware, which can be any hardware, with the applications above it. And changes could be separated and enhanced based on the needs without having to replace or modify the hardware, which again, it enhances the flexibility in terms of the usage and then applicability of the network. Here an example of NFV, how it makes the network kind of more open, more competitive, and kind of capable of using different functions and elements from the shelf that could make them kind of adjusted based on the needs in a much more flexible way. Network slicing is another very important enabling technology for 5G or capability that it allows 5G to steer resources towards a specific use case. It provides core resources or makes a core kind of a logical network, a separate logical network to a specific use case or application. With this, it enhances the security, but also it addresses different requirements that different use cases may have. For example, some use cases may have reliability and security requirements, some of them more rigid, for example, latency requirements and so on. So network slicing provides this capability to adjust and tailor the needs based on specific use cases by allocating specific resources from either the core or radio or transport side as well. In order to make full use of 5G capabilities in terms of network slicing, end-to-end network slicing is very important, is needed. At the moment, we only provide, not us only, but the industry in general, there is no end-to-end network slicing at the moment available. It's on the core mainly, because vendors are not ready yet with this feature on the radio side. But again, even with the core side only, there are some drastic improvements in terms of the services and the capabilities allocated to specific use cases and applications. Our test beds support network slicing, but again, it's only from the core side, as I said, because there are no products available, radio products that would support network slicing yet. And when I say radio products, I mean 5G radio products. Cellular IoT is another very important technology, and it's to address that one of those three key capabilities that, as I said, high density. When I talk about cellular IoT, I generally mean narrowband IoT, one of the two ones, because there are two cellular IoT technologies, LTE-M or CAT-M technology for IoT, which is based on LTE and 4G, and narrowband IoT, which again is based on 4G, but it requires a new radio interface. So it's completely new radio interface, and it's much more efficient in terms of the battery life and in terms of the life of the device itself. But again, these two technologies differ from each other based on the needs and requirements. If we have a need for sensors that would generate bigger messages, LTE-M is better because it goes over 4G and requires the setup of the bearer. While narrowband IoT, it transmits much less traffic, short messages, and it can go over signaling channel as well, which means make it more efficient and more efficient in terms of the battery life as well. So it all depends on the needs and the requirements for specific use cases and applications. These are some of the applications where narrowband IoT and LTE-M could use, and you've probably seen some of them that MOOAP, there is a MOOAP, for example, that has a sensor, a cow has a sensor, for example, and we can see when there is any problem with the cow, whether it's not healthy or ill or not, and so on. Small cells I know I'm running out of time, but I think I got a few more slides. It's another enabling technology that helps 5G, and actually 5G would not be able without this. The reason is because of the need and the demand to provide massive broadband, very high data rate. At the end of the day, everything is all physics. We can't have or provide a high data rate if you use macro cells because they are so apart from each other, and physics would not allow that. So that's why we need high density of cells, and small cells is the technology that is driving 5G and the adoption of 5G because of the capabilities to also support massive MIMO system, but also to work in a different range of spectrum, like shared spectrum, millimeter wave spectrum, and so on. So small cells is being seen as a driver for the 5G and our adoption, and it's something that we will see more of them during the next deployments. MIMO is another very important one, and when I talk about MIMO, initially we saw some 2x2, 4x4 MIMOs, which means 2 antennas on the transmission side and 2 on the receiving side, but now that number is increasing to 8x8 or 16x16 and even more based on the needs. And one key or very important feature here is to mention is the beamforming, which specifically for the early deployments of 5G, like for fixed wireless access, was very important because it allows the steering or the capability to steer the beam towards a specific case. For example, we have an antenna next to a stadium, and one day, for example, the stadium is full of fans. An antenna can steer that beam towards the crowd in order to provide better services, which in a much more efficient and smart way, which was not the case before MIMO or massive MIMO was introduced and then developed. What does 5G, or where is 5G today in terms of standards? When you talk about standards, 3GPP is the main body that develops 5G, and they started with, and they work on releases. So every major generation has a number of releases. In case of 5G, they start with release 15, and release 15 was to be based on 4G core with 5G radius. And all the deployments in the world at the moment are release 15 based. Only now, recently, last month or so, we started to see some early release 16 deployments, but again, we are still at an early stage with release 16 because release 16 was completed only last July, and usually take between 9 months to a year to kind of start with a commercial deployment after a specific release has been completed. Other releases are release 17, which is ongoing and is planned to be finished by September, October this year. How do they differ in terms of the capabilities? Well, the release 15 was focused mainly to improve the throughput, the data rate, and the IoT part, the high density part. There was nothing done on release 15 in terms of the reliability and latency. That actually comes more in release 16 and 17. So even if somebody today claims that my network can provide you 1 millisecond, that's not true. There is no 5G network that can provide one millisecond latency today. In our testbed, the best latency we have, it's 11 milliseconds. But again, that's very good when you compare with 4G, which is between 40 to 70 milliseconds latency. But 5G, even with release 15, can provide between 10 to 15 milliseconds. In terms of the deployments, where does 5G stand today? Well, we've seen a lot of deployments in the world. UK, the deployment started in 2019. All the deployments are still release 15 based. Talking to the operators here, they don't plan to have release 16 or standalone based deployment before mid next year or even end of 2022. But there are so many test beds now that kind of started to think of having a standalone. Our test bed, as I said, will be upgraded to a standalone deployment or implementation within the July timeframe. Release 16 with 15, it's more kind of functions were identified in 15, but half of them were not addressed, and those were forwarded or carried over to 16. So release 16 is more focusing on enhancing those functions that were identified in release 15. Why is 5G important in practice? Well, we said that 5G has those three key capabilities around which all the use cases and applications are designed, defined, and built. And those were massive mobile broadband, massive machine type communication, and ultra reliable low latency communication. Now, 5G is important because through these capabilities, it can tailor and it provides support and solutions for almost any use case that we can think of these days. So the combination of these capabilities make 5G unique and flexible in terms of providing those capabilities and support. So it's the fusion of those enhanced bandwidth, low latency, and very high density that makes 5G unique in that sense. In terms of the environment, again, it has a major role to play. And actually, the way I define environment, in my view, environment is not a vertical sector or market. It's more horizontal because it spans across different vertical markets. So almost every vertical market that uses 5G and has some impact on those markets will be reflected in the environmental horizontal sector, I would call it. So 5G with those capabilities, and as I said, all those capabilities are around these capabilities that I mentioned, is considered to be an enabler of energy efficiency because it helps all the sectors to be more energy efficient. And those either through like low latency, and which means more content can be transmitted during a specific time, as opposed to like 4G, for example, to download a movie, you would need, for example, 20 minutes, while with 5G, maybe you need half a minute or 20 seconds. So again, that's where the energy consumption comes into effect because it's less time available to download that, and it's more efficient. 5G will help different industries and governments to hit their climate goals. And probably, I mean, you know better than me those climate goals defined by UN that are very rigid and strict. And actually, 5G is helping a lot in that sense because of these capabilities, as I said, to be able to adjust and tailor the needs based on applications for specific use cases. In terms of the use cases, 5G can be applied and can have an impact almost in every sector. I just listed some of the sectors here with some use cases where 5G could be used and have an impact, like smart city, for example, but there is no clear border between smart city, for example, and the environment or the transport, because they are all part of, in some way, they are part of smart city. So in the context of smart city, we have, for example, congestion monitoring. 5G, because of the support or the capability to support the high density, it can support different sectors. It can, for example, measure the congestion, the traffic congestion, for example, on the road, and based on that, on real time, local authorities and smart city authorities can allocate the resources to avoid the congestion, for example. So it's a better customization of city resources once they have more information based on the congestion provided through 5G, for example. Others are waste management, V2X communication, which again, V2X is a vertical sector itself, but also is part of smart city. Crowd management, like, for example, when we have different events, concerts and games and so on, it helps the local authorities to better manage the crowds in terms of providing better resources to them at specific location, at specific time. Street light control, for example, 5G can enable street light management, like when there is nobody on the road or driving on the road, for example, they can either dim the lights or turn them off completely. So it enhances the management of this, and as such reduces the power consumption and energy consumption for that. Others like tracking for social distancing, specifically now in the COVID time, is very important, and 5G actually has been deployed in few cases that I've seen, like Liverpool, for example, an example in Liverpool, 5G was deployed just to manage this part of the social distance and tracking enforced by the government. Other sectors, smart grid, again, actually energy sector is, I would say, one of the sectors that benefits the most of 5G, because 5G, it helps this sector to enhance the utilization and avoid the leakage of or waste of energy. And that's that by connecting grids directly over 5G, and as such, having thousands of sensors that would detect any kind of different pattern or behavior of the grid, and as such, trying to achieve early diagnosis of any problem there. And with that, it would also help to reduce the downtime of grid in this case. Agriculture, which is again very much related to your group, it's a collection of real-time information on fertilization, livestock, crops moisture, herd management, and so on. So again, 5G started to be used in these sectors, although kind of the adoption is a bit probably slower than we would like to have seen. Tourism, as part of this, our project actually, but also past project of Digital Catapult, we provide a number of projects in the immersive sector, usually through tourism. For example, with Bristol, we worked last year to support kind of tourism by connecting AR, VRs over 5G, and as such, providing better user experience for the tourists to visit the city and so on. And healthcare is another sector that 5G is being considered seriously, and we will see some deployments very soon.
Xhafer, sorry, we've lost your screen, your presenting screen.
Oh, really?
Yeah, yeah, just not long ago. And we only have a couple of minutes left as well.
I think I got just a couple of more slides.
Yeah, brilliant.
Can you see the screen now, maybe?
Yes.
Okay. Yeah, so in terms of the sectors that benefit the most from 5G, it's very hard to kind of identify all of them, but I came across that these four are the ones that actually they benefit the most, and actually these four are the ones that are seriously considering early adoption of 5G. And like energy sector, and as you can see from the diagram here, actually, as you can see, the consumption is huge here, and the improvements with 5G would be immense, very huge. After that, manufacturing, healthcare, and transportation. Transportation, again, it can be part of smart city, but it can be a separate sector on its own as well. Specifically, transportation is important because it's considered to be that it releases a lot of carbon, kind of gas house emissions, and in that with 5G, it's expected to improve a lot because of the need to kind of make it more efficient, and as such, it helps through the sensors and different parts of connectivity that makes transportation in general as a sector, a specific sector, very, very efficient. Healthcare, again, social distancing, remote diagnosis, remote CT consultation. We have started to see some real deployments in Asia, specifically in China and in Japan in this part. But I think we've seen some early deployments also in the UK, where 5G is being used now as a technology to provide this remote diagnosis of specific cases. How green is 5G itself? Well, we're talking all the time here that 5G helps other sectors to become greener and to become more energy efficient. But actually 5G needs to be more energy efficient, because as it is now, like 4G and even 5G as well, they consume a lot of power as well. The reason for that is, otherwise 5G is more efficient for about 90% than 4G, because of the high connectivity and this need for high data rate all the time. It's very challenging to keep 5G very efficient and very kind of environmental friendly and still being able to connect all that. So that's why actually 5G itself needs to improve in terms of energy efficiency. And when it comes to that, this has to be on an end-to-end level, which means on a network side, on a site level side, or on the base station side. And base station actually is the element of the 5G that consumes the highest portion of the energy, and is very important to look at that. So again, 5G helps all the sectors, but again, the industry is looking as how to make 5G even more efficient in terms of the power consumption, because at the moment, with all the demand coming and all these high demand for connections, it's very challenging to also keep it efficient as we would like. I think these are the last slides, just some points to take home. 5G is complex, but it's very powerful technology. It's very flexible in terms of the capabilities and the features that supports. It can adjust to different needs and requirements. It's a single technology for public and private, and for indoor and outdoor. Provides better user experience. It supports a wide range of spectrum, and it at the moment is mainly based on release 15, but actually to get the full extent of 5G capabilities, we have to wait for release 16 and 17, which for release 16, we just started to see some deployment, but release 17, we won't see any deployment before probably end of next year, because the specification itself is still being standardized. And the very last slide, 5G has an important role to play in helping all the industries in terms of energy efficiency and to become sustainable. No technology alone can help the industries achieve their environmental targets. That's why I mentioned that 5G needs network slicing, needs MEC, needs SDN and IoT, but also needs artificial intelligence and IoT. Specifically, artificial intelligence is very important because it helps to make use of all the data generated by the sensors and process, and after that, make use of that data and make the network itself very smart, very intelligent. So intelligent networks is a combination of 5G, AI, and IoT altogether. And only all these three together can make an impact on the environmental to help other sectors. And I think that concludes my presentation. Sorry for going a bit over time.
That was wonderful. Thanks so much, Xhafer. So just a couple of quick questions I think we've got time for. One is talking about 5G being a game changer for environmental applications, especially in rural and remote areas. Do you know what the timeline is for full deployment of 5G technology in the UK?
Well, if you talk about the non-standalone release 15 based, all the operators have deployed 5G, but not everywhere. Now, full deployment scale, I don't see it would happen before end of 22. Okay. And that may still be release 15. So in order to get the full potential and see the flavor of the latest technology or latest version, I think test beds are still the best now, because they are ahead of the mobile operators, because mobile operators are big and it costs them a lot to kind of upgrade everything. But we won't see full coverage of 5G, kind of 98% of the country before maybe mid next year or end of next year.
Okay, wonderful. Someone's asked about the nomenclature around MEC being a bit of a confusing name. Edge computing,
yeah.
is
MEC,
true computing.
MEC, yes,
embedded on the end device itself. They're saying that MEC looks more like distributed cloud with localized server application server.
Well, as I said during the presentation, the location of MEC or multi-edge computing, as it is known, it's not defined. It can be anywhere. So we may see some deployments of that feature even all the way closer to the customer or on the phone, for example. At the moment, mainly is kind of MEC helps to kind of distribute the cloud and make it more kind of fog-based or kind of edge. So MEC can serve as a small cloud, but at the edge closer to the customer in order to provide much better latency and also to offload the transport. some people maybe sometimes confuse MEC with offload, local offload. Actually, local offload is a subset of MEC, but MEC can do more than that. MEC is a small core at the edge, and it helps to make some local-based decisions without having to go via transport and then core side.
Okay, and a question from Joseph. He says you've described the construction of the infrastructure and what it is, but from a production perspective, how quickly do you think manufacturers of technology can use the new infrastructure that there will be? And he's mentioned like recognizing the history of 3G and 4G.
Well, I don't know, it can be a personal view, but actually I see manufacturing to be ahead of the other sectors in terms of the 5G adoption. Specifically, and I had a lot of meetings last year with big names like manufacturers here, Siemens and Seagate and others. They are thinking very seriously of deploying 5G, and some of them still have not decided whether it's going to be completely private 5G, because 5G can be private setup deployment, but also can be a public one, or it can be a slice provided by a mobile operator. So again, from their point of view, it's kind of private setup. But yeah, manufacturing seems to be a bit ahead of the others in terms of the 5G adoption, because it provides a lot of benefits to them. It's not security only, but also latency, reliability, security. These are the key concerns of manufacturers when it comes to the new technologies.
Okay, wonderful. Thank you. There's some more questions on the chat, so I don't know if you're able to see that, but if you could maybe
I can go and open chat.
Yeah, follow up on the chat with some of the questions that have come through and some of the discussion. That'd be wonderful. And yeah, anyone else who hasn't seen that, if you click on the chat, then you can kind of follow what people are saying, and
I think for the sake,
so that would be great. So I'll pass over to Pascal.
Yeah, for the sake